Hello and welcome to another Red9 demo. This one's particularly important. This is a really key part of the Red9 process and of the ProPack. Today we're going to be going through animation binding and more importantly the process that we call proto-bind, which is the ability of taking animation data from one completely arbitrary skeleton over to the Red9 PuppetRig and indeed any custom rigs and doing it en masse and how we handle the data. So we're going to start with, we'll just go through the history of this really. Proto-bind kind of stems from a masterclass that I did way back in 2008, no 2011 I think it was. And it's still part of the Studio Pack. If you download the Studio Pack you get this thing, Animation Binder, and if you open it up there's a link to the masterclass that with me looking a lot younger without a beard and God knows what. But effectively it's the same kind of process. The process is we have a file and the file has a skeleton in it and a rig, and there is a definition between the two that says this is the relationship between these two files. If you work with us and we do any Red9 rigs for you, PuppetRigs, you will get a binder anyway. If you're not working with us on the PuppetRig, there are still ways of doing this through that animation binder UI. Obviously from ProPack and from the internal stuff we've done an awful lot of additional work to help the process. This is a binder file. The binder file consists basically of the rig referenced in under the namespace that you want that particular file to always be, and a skeleton which is a skeleton that will drive the rig. And it's the relationship between these two. Now there's a reason it's a file. Before we started doing this years and years ago, we started coding it up to say this is how a biped should bind between the rig and a skeleton. And the issue with that is we end up with clients who have specific nodes, specific joints, specific handlers for game situations. It might be IK control points, it might be any bind data that they want to take across from one situation to the next. We also have clients using the same system for taking data between Maya and Motion Builder and back again. So we have this, this is being effectively driven a lot of the time by, initially by Cloud Imperium for their Maya to Motion Builder process and getting the data back and forwards. So the actual process itself is available in the Red9 asset browser, which is up there, Pro Asset Browser. And in the asset browser, when you select anything that is an FBX, if you right click, you get this option Proto-bind, which loads the UI up. It's also now available as of the latest build just here, so you can load the same thing. You'll notice that this goes red. And the only difference between the one from the file menu and one from the browser is the browser will fill in the FBX and lock this data off, because obviously the files are bound to the browser itself. But that's the only real difference. The browser itself obviously has the capability of doing batching, and that's a really key stage of this. For example, we have this being used by many clients at the moment where they might finish a game project, they might have several thousand animations from game, they've got a new project, they've got a new skeleton, a new rig, and they want to push those animations and remap them across successfully to the next project. Well, this is exactly how we do it. So that's the basis of it. If we open the UI up a little bit, we'll just go through it briefly before we get into the nuts and bolts of the thing. So we have the FBX file, which is obviously, as I say, I've opened this through the browser, so that's bound and this is turned off because there's no point. The binder file, which is this file I've got here, which is the file, which is the relationship file, if you like. Now you'll notice there's a little drop down here. When you work with us as a client, you'll get a project file and a project management file. You can have as many different projects live as at any one time and switch between them. And inside the project data, there is a key for binders. And you'll notice that those are the binders that show up in this UI here. So as from a TD standpoint, you can set the binders and which binders animators can use at the project level. And they will be exposed to your animators without them having to dig in and find which files are the latest versions, etc. We have file options. This effectively controls what the system will do. So this controls how that FBX will be brought in and mapped to this skeleton in the binder file itself. Now we have output options which control how we bake the data down, what do you want to do with it, how do you want to output this data and in what format effectively. So those are the output options. So let's get into something, let's go straight into a complicated file and just to take you through what is actually available on this thing. So what I'm going to do is I'm going to do HIK connect. We'll go through all these options shortly, but I just want to give you an idea of what we're actually about to do. If we load this file up, this is, oopsie daisy, excuse me. This is this file here, Fight 3. So we're going to load this file, Fight 3 up. You see there's just FBXs in this folder. I'm going to do that one there. Again, we'll go through these options. I'm going to bait the rig. I'm going to make sure everything is on the whole frame number. We're going to filter, which is Euler filter. We're going to save an R9 anim. The R9 anim is our proprietary animation format. Very good at building files, very good at being able to pass files around and load files onto rigs dynamically, which is really good. We're going to save a Maya file off, and we're going to save a play blast off. Now the play blasts are all controlled by the new export settings, which are just here. And what that will do is, at the moment we have custom camera control. We're going to do a QT output movie. We're going to have a camera tracker on the thing. We're going to show polys, NURBS, etc. Wireframe unshaded. That's all the functionality that this thing will draw through. And we'll just run that process. So we've got this one file. It's going to open a new file. I'll open the binder, drop this FBX on it, and do all of these processes. Now while that's running, we'll basically just take you through some of the keys of this. We've had a few projects recently where we've had entire projects, 2,500 to 4,000 files of FBX animation data. An important fact with these is that these are set up for games, so they'll be set up with the correct names, the correct start and end points. All of that data will be set. And what you want to do is, when you're doing this over to the new rig, you want to propagate that data. You don't want to lose some of this data, because the time range is very important, specifically for games. This has just generated all those files. We'll take you through the files it's created. But what you'll see is, if we open the exporter up for Red9, this file has already set itself. So it's set the fact that we're running flight 3 of the FBX. It's set that in the export loop. It's set the time ranges to be the internal tape ranges within that FBX. This FBX was, I think this is 24 frames a second, which is why we've got this strange 1.2 frame start. But it's propagated the data from that into the exporter, waiting for you to then be able to output all that data. So it's maintained all that important, crucial data. If we come back into the folder where this file 3 left, there's our Maya file, there's the R9 anim file, and there's the movie it's generated. And what you'll also see is the movie has a camera tracker. So you get a nice focused video of what's going on, so you can, for previewing and for analysing what you've got in a mocap delivery. That's a really useful thing to be able to do, especially if you've got runs that are running 10 to a dozen off screen. You notice the camera actually isn't maintained. That's the data. The camera is dynamically built during the play blast process. Okay, so let's go through some of the basic options, shall we? Let's start with a typical scenario. In this folder we've got a load of FBX files, and these are all on the same skeleton that the binder is. So the skeleton internally of this binder file is the same as these FBX data here. Now this is typical of what you do if you were working with a mocap facility. You would generally give them the skeleton that you want the data solved to, and they would usually give you back either FBX data or the data already bound to your rig. But in this case we're talking FBXs. So these are all on the same skeleton. And because of that, we can use this simple one, which is update animation. So what I'm going to do is I'll pick one of those and we'll just go run. Now that will load the binder file up, and it will drop the FBX data over the top, which is what we've got here. Okay, nice and simple. Now, because I didn't bake that off, and because this is the same skeleton that we've got internally with all of this, I can quite easily just update these. So rather than actually loading it through the binder, I can literally just drop those FBX takes directly over the top of this file, just to kind of get an idea of what we've got in this delivery. If you had several thousand animations and you wanted to check one folder full of them, you could literally just run through these and go, yeah, that one's right, or and so it's a very useful thing to be able to do. However, if you wanted to get all of this folder onto the rig, what we could do is just select them all, Pro to bind, update, bake, put the filter on, and decide what we want to output, either a R9 anim, a Maya file, or a play blast. The play blast is a new one. We'll go through that in a second. Now, what sometimes happens is, particularly if you're working with MoBu, is that sometimes the FBX data can come in with namespaces, and that's an issue because the FBX update anim doesn't deal with namespaces. So this is where reference copy comes in. This is the same kind of situation, so the skeleton that the FBX has got is the same as the internal skeleton of the binder, but rather than using update animation, we're using our own software, our own system of referencing the data in, finding a skeleton within that referenced FBX, and using the R9 animation copy systems to handle the animation transfer, so it bypasses the naming issues, etc. But the same kind of thing. And then we have the more complicated one, the HIK connect. Now this is probably the biggest one and the one that we've done the most work on. The idea behind this is that, let's say you've finished a game project, you've got 4,500 animations, all engine ready, and what you want to do is you want to put that onto your new skeleton because you've got a new character, a new rig, new game project, etc. How do you do it? So this relies on the HIK plugs. The problem is, most of the time when you start a project, the FBX data, let me find the folder, where is it? That one there. The FBX data will just be skeleton data and it won't have a HIK definition. So at this point you're kind of stuck because you need to get HIK onto this before you can use any kind of remapping. So let's have a look at that now, shall we? So what I'm going to do is inside this folder where we've got all these animations with no HIK plugs on them, we've also got a Maya file. And if I load that Maya file up, open, nope. Inside the Maya file, we have this skeleton. And within the skeleton, we also have a HIK definition. So we'll just push that over there. We also have a HIK definition. So there's a HIK definition all set. If you've not used HIK before, it's a really easy process. You literally put the character in T-pose, and one by one you go through the joints, right click and assign. This has to be open. You have to assign them. Okay. Not going to go through that in great detail. There's plenty of reference for that. The key is that we need a HIK definition. So that's that done. If I go back to the FBXs, so what we need to do now is propagate this over to all these FBXs that we have here. And that's a really simple process. We select them all. So we've got the file loaded already with a definition in play, and all we're going to do is right click, Pro, Update and Save. And what that's going to do is it's going to go through each one of these animations, see how fast it is, and that's it, done. So if we load any of these up now, they've all got HIK definitions, which now means that they're open and ready to use the HIK binding systems that we have within the Red9 stuff. So that's a really important step. Okay, let's just go through some of the options for the more complex binds in a little bit more detail. We're going to go through the Connect HIK, and we're going to go through some of these mapping modes and what they do. So we'll do one by default. I've opened this up from the file menus, primarily because when I do so, this UI doesn't close down every time we hit it like it does out of the browser. Open browser, I'm just going to load this up. So let's see what happens. And I'm not going to bake it because I want to show you what the actual mapping is happening. Let's push him over there somewhere and we'll get rid of that. Okay, so because of the differences in the scales of the legs, the length, the limb lengths, get that out of the way, you can see that our character actually drifts away from the target. Okay, now this might not be an issue. It might be that you're trying to preserve the animation shape itself, but it might be that you need the contacts preserved. It might be that you're walking towards a door, you have to open a door, therefore you need to reach that door in the correct place. So that's where these different mappings come in. None just means it's going to do no attempt at doing anything, it'll just do it as it's currently set in the binder file. Default will reset the binder file as it comes in, so it'll reset if you've got any of the specific remapping set inside the binder, that will reset them in case you needed to on a per file basis. We have preserve contacts. Now preserve contacts will try and preserve the actual contacts, but what it won't do is it won't turn the match source on, and without that this character isn't going to match the distance that this character is walking. So what we're going to do is we're going to do the same thing, but we're going to turn everything on, which is this one here. Okay, and if you watch this, if we do that, you'll see that it makes a much better attempt at trying to match the positions. So we've got the grey guy, which is input data, and we've got the on anim rig, which is sat nice and squarely underneath that data, and you see it's trying to preserve things like hand contacts, feet contacts. It also turns on ground plane contact as well. So if we were to, for example, grab this character and bounce him under the floor, you see our rig stays nice and firmly on the ground. That's also turned on. So all of these little tricks are turned on. The other thing, because I didn't bake it, is what I can do is if I really want to try and match things a little bit better, if I were to scale that guy down a bit, he's scaling within the bounds of our character, which means that the matching is going to be a lot better. We're not hyper stretching arms to try and match a point. You know, we're going to get a much better fit. And there's some really nice data taken across, and that's without doing any work at all, really. So these are really useful. And then these two options here, the use current we probably won't go through it. It's kind of null and void really now. The use current will just assume that this binder is already loaded and drop the data to it. Open binder does just that. It will open the binder, do the transfer in that current binder scene, and output the data. depending on these output flags. An import binder allows you to stack them. So I could quite easily build another one in and load another FBX over the top of this file. For example, let's load that and we'll bake it off. Yes, go. And it will just import it into the same scene, and you can build multiple sequences up within the same file, which is really useful because if you're trying to do this data on multiple rigs or multiple characters in the scene, you might just want to kind of compile a cutscene from multiple FBXs. This now allows you to do it, so it's really useful. Okay, let's go through these final output systems and what they're going to do. I'm going to pick that one there, I think. Let's just do file new, clean the scene off. Okay, so Perforce I don't think we've gone through. That's quite simply if your project is a Perforce project, which is defined by the project manager down here. If this was Perforce enabled, anytime we output any of these options, anytime it says save, the file that generates will sit in your current Perforce check-in list. It won't check it in, but it will just add it to the list, or it'll check it out waiting for you to add it. That's quite useful. The whole frame expand does just that. You'll notice that when we did these, we had a warning that the incoming FBX was 24 frames a second, but the Maya file was 30 because the binder was saved at 30 frames a second, and that's our current working units, which means that we had subframes. This gets rid of them. So when it bakes it out, it'll bake it per frame on the whole frames. That's all that does. Obviously, bake to rig does the baking. Filter does a Euler filter. So these three are kind of usually on when you're going to commit straight to the rig. The import one is this one. This is a new one. In fact, these two are both new. I'm going to use this file as it currently stands, and I'm going to show you the difference in the two systems. So we're going to import this file, bake it off, filter the curves, and we'll show you what happens. Okay, so nice and quick. There we go. Now then, because when we make a binder through the Puppet rig, we also bind the FK. What I can do is I can see the difference between what the FK does and what the IK currently does, and you see you get a pop. Let's move that out of the way. Now that pop is there not because it's a mistake, but that pop is there because that is the standard behavior of most IKFK matchings on a spline-based system. We have the hips, we have the chest, we match the spline between the two, but because of arc length and because of differences between FK and IK lengths, you always end up with a bit of mismatch on the top. Now, if you followed any of the videos of what we've been doing, you'll know that the Red9 Puppet also has an additional algorithm that we use when we do an IKFK match where it tries to properly fit the spine data. And if I do another run on that, I'll keep it open. No, I won't. We'll just do it as another pass. You'll see that it does a second pass. So it'll load the data up. You'll see it just, there we go. That's it scanning through, doing the matching systems. There we go. Right, now then, if we do the same thing again, we pick the same kind of frame, something where the spine would normally shift, and we do that. You'll see the spine, middle of the spine, will try and adjust itself because we don't have any matching over the twist. But if you look at the most important part, which is the top of the spine, the chest area, is absolutely rock solid. There is no difference going on in that. And that's because of this spine fit. That's what our IKFK matching does when it hits the spline data. Again, the twist, because it's spine IK and because we have a single twist node within it, that will always be slightly different. But the crucial thing is this top is rock solid, and that's a really, really important factor within this setup. And then finally, location track. Let's just go back to something where it's running, but I can't remember. Fight, probably. Run. There we go. That's an obvious one, isn't it? Okay, and we'll turn the locomotion tracker on. In all of these, one of the issues with HIK is that the reference node, which is the very top of the skeleton, never gets recalculated, never gets mapped over, and that usually leaves you, particularly if you're a game, with a locomotion route, which is generally the top of the hierarchy, left where it is. If I just turn the output skeleton on, you'll see there's our locomotion route and there's nothing on it, which can be a bit of an issue. So this new one here, locomotion track, will try and do that. It'll try and mimic what HIK should have done in the first place. And we'll just do it on this file here. I've left them all on, so it'll do 3 passes. It's not very, there's the spine, there's this fit. So if we do that now and we try and find our data, there we go. What you see is there's the locomotion route, and that's now tracked. So it's a tracker that runs per frame on the data to try and sit that at ground level projected down from the cog. Again, just a really neat little thing to add in to the end of it. And then finally, we've got the 3 save modes. So we've got the R9 anim save, which is our R9 animation data format. Save the Maya file. The Maya file will become the same name as the FBX take. So this is run1. Maya file's been renamed run1, sat next to the FBX file. And the save play blast, which we quickly went through, is these settings here, which is all the all the play blast management systems that we have. Again, we'll probably do another separate video on that. This is all linked to the exporter, but these 3 options all get called from the exporter, which is why the perforce management also kicks in. That's about it, really. So kind of to summarize, the whole purpose of Pro to Bind is to enable you to batch reuse animation en masse without doing any particular clever work. It's the kind of thing that, you know, you don't really need a TT to do. It's not that difficult. Putting a HIK definition on them is a piece of cake. You've seen how easy these are, and it's just a case of transferring the data, and you can do it en masse. Very useful, very powerful systems. Thanks for watching. If you've got any comments, by all means, drop us a line. Thanks again. Bye.